Hello everyone, here I will carry out the SOLIDWORKS flow analysis on safety valve. Okay, so we'll consider this pressure relief system valve, and you can see all the required components are already available here. By using flow simulation wizard, I'm gonna just define the project name as draft test. Can change the unit system, so here for the pressure I'll add the bar, and for length millimeters, and the analysis type should be internal for me here, so I'll keep as it is. And the fluid, I'm gonna consider air into account, so that's done. Other parameters I'll keep each and everything as default, the pressure and the temperature and all. Yep, the computational fluid domain has been created accordingly, but that is not the region where I need to deal with. I'm gonna define the lids by using the advanced tool, that is create lid. The software gonna create the lids automatically. Now by using the computational fluid domain, I'm gonna just set it out only the region which I need, and I'll simply hide it now. And let me define the boundary conditions. So for the inlet, I'm gonna consider the static pressure at this phase. The value should be 2.5 bars. So this is simple consideration out for the practical scenario. Okay, and outlet I'll define as environmental pressure, so no changes over there. So as per the environment, what is the pressure is it, that should be taken into account. And for the goals, I need to calculate the pressure as well as the flow. So globally I'll define the static pressure and the total pressure required, and even dynamic pressure required. And even I need the surface goals, in the sense on exactly the surface I need the pressure should be considered. So I'll define the surface goal. On this phase I need the total pressure value, and even outlet mass flow rate and the velocity I need to calculate. Again, I'm gonna select this phase over there. I'll select the velocity, the maximum velocity, as well as the mass flow rate at that location. So once you set your boundary conditions, you can utilize the mesh. So here you can able to define the advanced as well as automatic and manual meshing. So here you can use the level, that is the mesh level. So from 1 to 7 you can set it, and you can use the manual method so that you can mesh as per the advanced criterias and the regions where you want to exactly mesh. But right now I'll use the default mesh. So I'm gonna run the study just by using these parameters. With that, you can plot the contour plots as well as the flow rate plots. So here you could see, so this is the total pressure plot, for the pressure varying from 0 to 4.8 bar. So we have achieved the convergence at 98th iteration. So it has run on an average of 120 iterations here to get the converged values. So to cross check the good plots, you can add the pressure plots and velocity plots. So here the pressure plot I'm going to define with respect to the planes. You can manually set it up here. I'll define the right plane, and could be able to visualize it. And you can refine your plot using these actors and add the streamlines as well as the mesh if you need it. So now I need velocity plot with respect to right plane here, and the maximum velocity at that region is 470 meters per second. And even we have the flow trajectory so that you can analyze how the flow is happening with respect to the inlet. You can even set the appearance types and the number of arrows, and you can even change the arrow types like balls and even reds, flat arrows and all. There are multiple variations are there so that you can have a better visualization results. Finally, you can animate it so that you can see how exactly it is happening. Now to deal with the goals, so I just want to cross check what is the pressure and the mass flow rate. You can add the goal plots. You can select goals from here, which exactly you are looking for. The total pressure and the mass flow rate surface goals I need. You can see the values at that particular phase. It is 3.91 bar and the flow rate is 2.6 kg per second. So here we have the advanced techniques to deal with. For example, if you are dealing with the results, we have the parametric study. Here you can use the what if scenario, goal orientation and design experiments. Let's say here we'll deal with the design and optimization. By using this method, you can able to manually define the initial boundary conditions. Let's say we have defined the initial static pressure at 2.5 bars, so you can set up the range to 2.5 as well, and so here 2 to 3. Okay, with that, what exactly want to get the results? So I want the total pressure and the maximum velocity results should be taken into account. You can define them, and with respect to these variables, you could able to see how the default experiments 5. You can create them. Otherwise, you can increase the experiments as per your requirements. You can manually type it. So these are the 5 experiments. So I need more. You can manually change it. So static pressure is changing from 2.7 up to 5 increment in a second. But if I define it as 10, the software automatically calculates the variations of the input, that is to give it. And once you run the study, you could able to see the results with respect to each experiments will be shown. The total pressure at that region, 4, 3 like that, and the velocity. Okay, so this is how you can carry out the multiple studies in one shot and you can get the results. There are some scenarios where you can deal with the what if scenario. Let's say I want to make the changes into the valve location, so you can set the distance parameters. So this is okay for me, the static one, so I'm gonna consider the 2 to 3 range. And but now I want to make the changes into the wall location, so you can use this distance mates, and it is right now 3.35 mm. I need the results for different values, so you can set up the discrete values. Let's say it is 35 now, 30, 25, 20 like this, and with respect to that locations you can get the results. So these are the advantages of this parametric study. So here you can utilize what if scenarios and design optimizations and all, so that you can get the results for all the set of requirements. So you can see there are 8 design studies, and with respect to goals, same thing, I need the total pressure and the velocity. So you can run this to get the results, and you can see the variations over there. According to the studies, the distance between the nozzle and the wall is changing, right? So 30 to 30, 25, 20, like that. And now you can directly switch between the studies. You can select this create project so that you can get the results of that particular design, and that configuration will be created, and with respect to that study, the results will be loaded, and you can just cross verify that results. Could see the configuration is ready. You can have the section view accordingly. And here you can cross check. So I have selected the design point 8. With respect to that, the distance of the nozzle position is at 20, and you can see that has been changed to 20. Initially it was 35. And to get the results you need to load it. So with the study, the results will be loaded, and you can just visualize the results. And from the study, like by using SOLIDWORKS flow simulation, these valve industries can easily able to predict the pressure and how much pressure they need to maintain to avoid the failures inside the tanks and all. So even how much flow rates they need to define by just selecting the static pressures or inlet pressure. By defining that, they can able to maintain and regulate the values. So this is the huge advantage of SOLIDWORKS flow simulation. Yep, that's all about the session. So we have gone through SOLIDWORKS flow simulation overview. Inside it, we have utilized the tools to deal with the pressure relief valve system, and also we have gone through the parametric study and what if scenarios and design optimization studies. That's all. Thank you. Stay tuned.